Welcome to HB Tuner's Ford Gen 2 Coyote Training Part 10. This training module, we're going to be taking a look at understanding our injector characterization data. Now, this is going to be breaking down how we convert a fuel mass into an injector pulse width by knowing things such as our low and high slopes, our latency data, understanding how we have an effect on both pressure and voltage to the injector corrections that we have going on. There's a lot of things to discuss. Let's jump into the tutorial so we can break down working within our injector data. Okay, so let's get started. We're going to be taking a look at working with our injector characterization programming within our Gen 2 Coyote applications. When we're changing our injectors from stock, we need to update all of our injector data. This is going to be one of the most important things that we program. If we get it wrong, if we put the wrong injector data into our engine control module, we'll find we have an error in our fuel delivery. And by introducing an error in the fuel delivery, we need to absorb that somewhere, we need to correct it somewhere. If we don't realize that we're putting bad data in, or if we're just using any kind of injector data, we might absorb that error into our airflow model. That'll create all kinds of problems because our Gen 2 Coyotes are torque-based, and part of where it calculates torque from is going to be airflow, how much air is coming into the engine. So we want to make sure that our fuel error is as minimal as possible. And if we're using good injector data, such as injector dynamics, we shouldn't have any error at all in our fuel modeling side of things. We need to break down how this actually works, but first I want to go and find all of our injector data information in a calibration file so you know where to locate that. So I'm going to be working with a 2017 Mustang GT calibration file. For this tutorial, you can find this particular calibration file in our HB Tuners Gen 2 Coyote training course folder, Mustang example files, 2017 Mustang, and then the 2017 Mustang GT is the file that I'm working with for this particular tutorial. This is a stock equivalent file, so all of the injector data here is going to be all stock information. Let's go take a look at this where we can find our injector data. So if we move in here from our engine tab, and we go here from our general tab, and we go across under fuel, we're going to find under our fuel tab, under injector control, we have our injector flow rate, our breakpoint multiplier, that's going to be signifying the difference between low and high slopes. We have our minimum pulse width, we have our rail temp modifiers, and we have our offsets. So all of this combined will give us a corrected injector pulse width. That's what we actually pulse and send to the injector to open and close, to spray a certain amount of fuel. And it needs to be precise because, again, if we go and deliver too much fuel or we under-deliver fuel, we'll have either a rich or a lean condition. If we have a rich or lean condition, we need to go and correct that in our fuel and airflow model. Now, if you didn't realize you had bad injector data, you'd absorb that fueling error into your airflow modeling side of things. You might absorb that into the MAF curve. If you have incorrect reported mass airflow coming into the engine or air mass coming into the engine, that can lead to the torque reporting being incorrect. And because everything is so heavily torque based in our Gen 2 Coyote applications, that can lead to all kinds of problems, from idle control problems to drivability problems to some kind of a torque limiter being in place. We want to avoid that. So we want to make sure that the injector data is programmed properly. And in this tutorial, we're going to go through what all these different various parameters and tables represent. And then we're going to essentially understand the modeling that goes on behind the scenes. And then we'll take a look at how we can use the template applicator to bring in injector data into our calibration file. It's pretty straightforward. I've made that really plug and chug using the template applicator, which we've covered in a previous training module. Let's jump in here and let's talk about the air and fuel model that we have going on in our Gen 2 applications. So we have an underlying equation where we translate a certain amount of airflow coming into the engine into a certain amount of fuel that we need to deliver. And that's going to be fuel mass is equal to air mass divided by target air fuel. This is going to be any mass airflow based car will have the same type of underlying fundamental equation. Doesn't matter if it's a Ford, a GM, a Subaru, they're all going to be the same. So how this is going to work, we have a mass airflow sensor fitted to the intake track of the engine. It's going to be registering how much air mass is coming into the engine at any given time. By knowing that amount of air mass, that'll go into the equation in that air mass section. Now we specify a target air fuel. The target air fuel at idle and part throttle would be stoichiometric, which is 14.7 to 1 if we're talking about the petrol gasoline air fuel scale. Now in this situation, if we know the air mass and we know the target air fuel, we divide the two numbers together and we can get a fuel mass. The fuel mass will be what we need to bring into the engine. Now we translate that fuel mass, typically in grams per second, into an injector pulse width by running it through all of our injector data right here. So it has to go through here, and essentially what it's doing is translating that requested fuel mass and putting it into a period of time that we command the injector to open and close to spray a finite amount of fuel. That amount of fuel needs to be correct, and it is relative to the injector size that we're dealing with. So if we change our injectors from stock, they're going to flow more. Therefore, that pulse width needs to change. A really small injector, stock injector, is going to need a longer pulse width to deliver the same amount of fuel mass into the engine compared to a much larger injector. So let's just say stock injector is something like a 30 or 40 pound injector, and we're putting in a 100 pound injector, a 1000 cc injector. That situation, the larger injector is going to flow a lot more fuel mass into the engine. We need to have a lot shorter pulse width to be able to deliver the same fuel mass. So the idea of being able to... Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.